It will be m, that one. So it will come and collide with the speed. This is the initial thing. So let me take it out that inch. Sir, you only said there's an inch and you are removing that one. Yes. And let me analyze the concept like this. Yeah. Now the particle, what happened, will come and collide. After collision, this will have velocity v1. This is the center of mass of the rod, no? Take O. So because of impulse acting, it will acquire linear velocity and also it will acquire angular velocity. But sir, you're not showing inch. Yes, I'm not showing inch. Let me call this is A, B, and where it collides, let it be P. When there won't be reaction at the inch after collision occurs, I want the value of x. So what is x? X is what I'll measure from here. I'm slowly moving away from the problem. Let me first discuss the idea, then I'll come back. It'll become very easy to analyze these options. Now, when there won't be reaction by the hinge on the rod, when the velocity of point A is zero, no? See, why the reaction of the hinge will come? If the point A moves towards right, the hinge orbit will exert force towards left. Agreed? If point A moves towards left, then the hinge will exert force towards right. Then you have to ask questions. So like point A is a fixed, and you are saying it will move towards right, towards left. Is it injured or not? It is injured. So where's the question of point A moving? See, like it is injured, I agree. But what is happening? Due to the velocity, what happens? See, rod is injured here. When the moment particle comes and collides, impulse will act. Due to impulse, what happens? Center of mass will move. And due to translative motion, all points will try to acquire the velocity of center of mass. So therefore, this point also will try to move with velocity of center of mass. But since it's injured here, no, so therefore the hinge will not permit. And also this impulse which is acting will set up angular impulse. So there are the velocity of point A, what happen? Due to translative motion, it will try to move towards right. Due to rotative motion, towards left. When the point A will not move, when the translated or when V2 is equal to say some L by 2 omega 2, then velocity of point A is 0. When velocity of point A is 0, what will happen? It will not move, then the hinge will not exert a force. Hinge in what actual exert force on point A? If the hinge will exert force on the A towards right. When it will happen? When the velocity of point is towards left. Hinge will exert force on the rod towards right when the velocity of point is towards left. Hinge will exert a force on the rod towards left when the net velocity of point is towards right. Hinge will not exert force on the point A when the velocity of point A is 0. Getting the idea? So I think I should bring a condition for what situations when velocity of point A is 0. If VA equal to 0, the hinge will not exert force on the rod. Okay, this is the inch. This is the inch. What we're discussing, this is the inch. Let's write equation. What is the velocity of point A? Velocity of point A equal to V2 minus L by 2. I think length of the rod, capital L. L by 2 omega 2. Then for no force, if the inch, if VA equal to 0, the inch will not exert force on the rod. For this condition, the hinge will not exert force on the rod. So for that, what happen? I'll put 0. 0 equal to V2 minus L by 2 omega. So therefore, V2 is equal to this is a thing. Okay, let's after this. Can I conserve linear momentum? Yes, because there's no force acting on system. Because we assumed it, no? Hinge will not exert force, not exert force. So what is the net force on the system along x? 0. Therefore, momentum is conserved. So initial momentum equal to final momentum. mu is equal to mv1 plus mv2, or u equal to v1 plus v2. Equation 2, this is equation 1. Then again, I need one more equation. Can I apply conservation of angle? About what point? About the point about which the rod is rotating. So let the rod rotate. Directly let me write here. So conservation of angular momentum. Conservation of angular momentum. And now your task question. About point 2. So how you can conserve? Because I say that there's no impulse by the inch. But the previous problem you said you should not conserve angular momentum about 2. That's all, no? You said angular momentum is conserved only about a. In this problem, again you are writing angular momentum about 2. What is the condition we assumed? The condition what we assumed is if there's no inch, if there's no reaction by the inch, definitely when angular momentum is conserved about O only. So why only about B? As about any point it is conserved, since the rod is rotating about its center, so I'm conserving angular momentum about point 2. The reason for that, because there's no reaction at the inch. We are assuming if such a thing happens, then m u into, so this distance will be how much? L by 2 or x minus L by 2. Why x minus L by 2? The total distance is what? This is x. This distance is what? L by 2. So this is a perpendicular distance needed, no? Or getting confusion, we will make it this y. So what is y is equal to? Mu y anti-clockwise should be equal to mv1y anti-clockwise plus io omega 2 anti-clockwise. I'll bring everything here. Let's get into the, okay, there's one equation we got it. So let's substitute all because we need things. So this will be u uy is equal to v1y ml square by 2l omega 2. M will get eliminated. Now u minus v1. Okay, this is, okay, this is equation 2. No? Now I'll proceed here. Further, u minus v1, what you can write? So u minus v1 into y, or u minus v1 is equal to L square omega 2 by 2lb. This is equation 3. Put 2 in 3. U minus v1, we can write it as v2. So this is equation 4. Solving 4 and 2. 4 and 1. v2 you write it L by 2 omega 2 equal to L square omega 2 by 2lb. This is y, sorry, symbol. So what should be the y is equal to now? L by 6. Where the particle should come and strike the rod from the inch at a distance x we said. So what is x is equal to? X equal to, shall we put L by 2 plus y? Anybody? Value of this? 2L by 3. Okay, now look at this. If particle comes and strikes the rod at a distance 2L by 3 from the inch, then what happens? There won't be reaction at the inch. There won't be reaction at the inch. I'm saying that one. There won't be reaction at the inch. So I'll put a broad statement. If a particle strike the rod at a distance 12/3 from the inch, no reaction at the inch will be there. No reaction force will act at the inch. There's the first case. There's the thing. Now, if x greater than 12/3, I think everything we have to show it. This is very fundamental theory. It is not don't take it like numerical. The minimum idea a student must have that one. No. This is when x equal to 12/3. The first case I'm discussing. At x equal to 2/3, what happens? The reaction at the inch. No reaction at the inch. No, I'm using word. Agree this? I think option A ruled out. Is saying non-zero. No, it will be 0. So this is ruled out. Next, for x greater than 12/3, in what action the reaction will act? There's the first case, second case. Second case, x greater than 12/3. I think we'll. Where we are? This one. We have enough space for x greater than 12/3. And tell me what conditions will come. Everything visible, please do make observation. X greater than 12/3. If x is greater than 12/3, what will increase? I think the impulse will increase, no? The impulse will act here, j into y, j into x. If x increases, j will be there. J into x will increase. Then what happen? The rod will have more angular velocity, omega 2. Then the velocity of point in what direction will be towards left. Then the reaction by the inch will be towards right. Able to get, so for x greater than 12/3. So how the reaction at the inch? Reaction at the inch will be non-zero and acts towards right. This is very important. So on what basis you can see? What happened to velocity of point A? Velocity of point A will be backward or towards left. VA will be, if velocity of point A towards left means the rod, the velocity of point A towards left means the inch will exert force towards right, no? So that's what I'm saying, will act towards right. I think this is very important. What we assumed is very important. With that only I should solve the problem. There's no other way. I should first discuss this equation 1, 2, 3, 4. At what point the particle should come and strike so that the reaction at the inch should be there. For the reaction at the inch to be 0, velocity of point A should be 0. I brought that conditions. This is imaginary. Yeah? This is a real. This is imaginary like this. Because if I show inch, you'll get confused. So therefore, I just put a rod. Velocity of point A 0 is enough. Sir, is it possible velocity of point? I think I discussed these ideas in yesterday's class. There'll be some point on the rod which can have 0 velocity. Can you remember why I discussed all this? To mentally prepare you that due to in such a collisions, there can be a point on a rod or there can be a point outside where velocity will be 0. Yes, it can happen. Now, if x less than 12/3, if x less than 12/3, if x decreases, j into x, the angular impulse decreases, angular momentum decreases, then the angular velocity here what you have, that L/2 omega 2 will be less than V2. So velocity of point will be towards right. Then how the impulse will act, or the reaction at the hinge will act. The reaction force at the hinge will be towards left. The force will act towards left. Sir, why you are doing all this? I think, see, you go to the machine, whenever your father opens the deck, no, there, the particular thing, the front part, no, when you open, no, do make observation. So many moving parts are there, no. When you go for servicing of your vehicle, do make observation. There are so many moving parts are there, and in some machines open where constant open, this will come in contact. And if this comes in contact, there'll be reaction. If there's a reaction, means what happened? Definitely the hinge will exert force continuously. There's a chances of breaking this rod, no. Therefore, where it should, this particle should strike. It should strike at such a point where reaction should be zero, and but still it should be suspended. We need all this in machines. You'll be surprised, in car, in bikes. We need this. Though I suspend, there should not be reaction at the inch. There's a method I'll follow. So now x less than 2L/3. Velocity of point A will be towards right. Reaction at inch will be towards left. Got the idea, no? So there's about this one. So what I did for rod, now what you should do? Any other rigid body? What are other rigid bodies? Triangular plate, square plate, rectangular plate. Again, the method is same. So on Friday, we'll take some other rigid body, some other shape. This I exclusively discuss for the rod. So therefore, what is this point x equal to 2L/3? It is called as a center of percussion. Let me get into the thing. So it's called like a center of percussion. Very, very, very important. How rolling motion is important, no? Like this center of percussion. So what is the idea of that? If a rod is suspended, this one, there should not be. So at what point I should apply impulse? Particle, no? Let me apply impulse here. I'll apply impulse here. Then this I'll call as a center of percussion. If I apply impulse here, no impulse at the inch. You just show like a impulse, any direction, no problem. Jx will be 0. Anyway, jy, there is no, it will acquire angular velocity, we are not bothered. Jx will be 0, that one. Because it will acquire, the rod will acquire angular velocity. Then immediately centrifugal force, jy will come. Anyway, that will not much affect here. The jx is what big headache in the machines. So if impulse acts at a distance, so for a rod, this is what distance? X equal to 2L/3. So I think I had to show diagrams, no? I'll just put it all one by one. Now I applied at a distance less than x is less than 2L/3. Above the center of percussion, there's a O. Center of percussion is somewhere here. Then how the impulse will act? Impulse, so it will be towards left. Jy will be there, I'm not bothered. Last thing. The impulse is acting here now. So the here Jx will act like this. I think I'm right. I'm giving all the things. So what is this? Center of percussion is at a distance of what? 2L by 3 for the rod. So now what you have in front of you? You can suspend any rigid body, triangular plate, circular disc, semicircular plate, cone, find out center of percussion. If you're really interested. See, JY, I know JY when it will act because of angular velocity, omega, JY will act. Anyway, it's of no use for me, no? JY will act like this. Because of omega 2 acquired, there will be JY. Because the pseudo force will try to pull it away, JY will act here. That will not affect much for me in the machines. That's why I'm not bothered much here. So that's why he's telling you try to see that one. Normal contact develop the hinges in. Normal contact. Normal contact means it's asking something in this direction. Backward on the rod, forward on the rod. So we are not bothered about this JY. Yeah? So this we are not bothered impulse along the rod. It doesn't matter much in the machine, so that's why we are not focusing much. In all the cases, JY will be non-zero. I'll put a strict condition. Jx will be non-zero. Here Jx is 0. Okay, there's a one very important concept. Please do analyze once. It can be.
Sir, in the first case, how is Jy not equal to 0?
Omega will be there, no more. Because when I apply impulse, it will rotate, no? In all the cases, the rod must have angular velocity. Because of angular velocity, what will happen? A pseudo force will act. Then Jy should come, no? Circular motion. Okay. Take one rod, try to rotate. You feel that rod is trying to move your arm away, no? That is what JY.
Okay,